All right. All right. Hi, everyone. Today I have the pleasure of introducing Kath Landgren. She is a postdoc currently at CU Boulder, and today she's going to talk about the disentangling climate polarization. Without further ado, go ahead, Kath. The floor is yours.
Thanks so much for the introduction, and thank you so much for letting me speak here today. I'm really fond of the MCRN, so really happy to be here. And today we'll be talking about disentangling climate polarization from a few different perspectives. First, just some of you know who I am, but just a little bit of context. I have always been into applied mathematics, and I was lucky enough to have an applied mathematics program in my undergrad institution. And so I always knew that I wanted to do math and something else. And I'm really grateful to have this trajectory. And that sort of indecisiveness has shaped my PhD a little bit, where I was working separately on complex social systems and atmospheric dynamics, but wasn't really bringing them together until my postdoc, where I get to do social dynamics and climate and computational social science more broadly. And that is also what I'm going to get to do in my second upcoming postdoc starting in the fall. So in mathematics of climate, and if you've been going to the MCRN Colloquium, you know this, we typically focus on physical systems, and there are these beautiful, rich dynamics, and you can find them on Earth, you can find them on other planets. There are a lot of things that you can learn, but what I want to highlight is that in order to tackle the issue of climate change, we need to understand the coupled climate social system, which is a little bit of a different perspective. So we have society that is going to affect the climate and how the climate changes can affect society. So you get these feedback loops and this sort of coupling. And so very broadly, that is the perspective that I'm interested in. But today we will be talking about a very small specific piece of this system, which is climate cognition. In short, climate cognition is how people think about climate. But there's also a long answer where we have individual level climate cognition, where people are forming their thoughts, and it gives rise to emergent cognitive phenomena where we have things like collective beliefs and collective decision-making and hopefully collective action about climate as well. And today we're going to focus on an even smaller piece of this small piece, which is this arrow over here gives rise to. So how does individual level social cognition give rise to all of these emergent phenomena? I will give a little bit more background before we dive into some of the more mathematical aspects. And today, overall, it will be a very data-grounded talk for a pretty mathematical audience. So please feel free to interrupt me with questions. It looks like we're a pretty intimate small group today, and really love talking about how data can inspire models. So climate change is polarized. This plot shows the percent of US adults who say that a given issue is important. These data are from 2020. Actually, there are new data as of last week from Pew Research Center, but I haven't updated the slides yet, apologies. What I want to highlight is that climate change and environmental protections are extremely polarized, where there is this giant gap between percent of Republicans who say that this issue is important and percent of Democrats who say that this issue is important. It is more polarized than guns. It is more polarized than immigration. It's more polarized than healthcare. Climate change is also not monolithic. When we talk about climate change, we're often talking about a lot of different things in this one phrase. But the things that fall under this umbrella are emissions and innovation, energy and transportation, as well as diet and agriculture. All of these things can get bundled together, but we can also look at them separately. And climate change is often misperceived. And this is something that I spend a lot of time thinking about. People are wrong about, for example, most environmentally impactful individual behaviors. So most people think that using energy efficient light bulb, or the plurality of people think that using mostly energy efficient light bulbs is more environmentally friendly and impactful than changing their diet. But this isn't the case. But of course, we don't just want to talk about individual behaviors. People also underestimate public support for climate policies. And this is the case in the US. And there is also a paper from 2024 that showed that it's also the case overall globally on average. And so what we want to know is why climate change is such a polarizing issue in the US when Americans overwhelmingly accept that it is happening, and how we can catalyze climate action across individual and collective scales. We're going to kind of take a tour of different mixed methods. First, we're going to look at what misperceptions people have using some survey data. I did not conduct the survey. I'm very grateful to be in the age of open science where a lot of the data is available. Then we're going to look at a network model to study what the underlying mechanisms are. And then we're going to look at the evidence for these mechanisms in the real world. We're going to look at news transcript analysis, and then we're also going to look at the analysis of social media. So let's dive into the data exploration. Overall support for climate policy is really high. So if you ask people, do you support a given climate policy, you get these estimates in the 66 to 80% range. And it's a little bit lower for taxes, and it's a little bit higher for things that are not taxes. But overall, people tend to say, yes, I support climate policy. But if you instead ask, okay, but what percent of people in your state or what percent of Americans do you think support climate policy? You're going to get these much lower estimates in the 37 to 43% range. And so in the survey from Sparkman et al., people were asked to estimate the number of Americans who are worried about climate change or support one of these four policies: carbon tax, citing renewable energy on public land, 100% renewable energy transition by 2035, or support the Green New Deal. And we can look at their responses and plot them over here, where all of their guesses are here on the x-axis, and we have a histogram, so the number of respondents is on the y-axis. And so the actual percent of people who say that they support carbon tax for fossil fuel companies is 66, then everybody to the right here is overestimating, and everybody to the left here is underestimating. And so what we see is that the center of mass of this histogram is well in the underestimation territory at around 37%. And we also see that barely anybody is overestimating. And we also see this interesting kind of two-peak structure where you get a peak at around 20 to 30% and another peak at around 50 to 60%. We can also look in more detail at the structure of these responses. So we can contrast by party affiliation. And if we split the respondents into Democrats and Republicans, we see that they both have misperception and they both have underestimation, but Democrats tend to have less underestimation. So they average out at about 47% over here versus Republicans who are averaging out below 40%. But here's another thing that really surprised me when I first encountered it, which is we can also split into different groups by media consumption. So here is Democrats who watch Fox News. And so what we see here is that Democrats who watch Fox News tend to have about as much misperception as Republicans do on average, and the overall histogram is even more right skewed than the histogram for Republicans. So this is our first hint that media consumption habits are going to be important in disentangling this puzzle of misperception. So with that in mind, let's turn toward modeling. The model that I'm going to talk about is going to be fairly parsimonious and simple, but hopefully it will give us some useful insights for tackling this challenge. We're going to deal with a very simple social network model where every node over here represents a person, and an edge between two nodes represents that they know each other's opinion about climate specifically. And the color here just shows different opinions. So I have my supporters of climate policy in yellow and opponents in blue. And then we can ask each individual supporter or opponent to say, oh, well, what percent of the people that I know climate opinion of support or oppose climate policy? And they can give us the kinds of estimates that people in the survey were asked to provide. And then we can ask every agent in our toy model to provide the same estimate. And so here, the way that I've constructed this example, the actual proportion is 70% support, and the the mean estimate is 71, so pretty close. So we don't really have widespread misperception over here. But of course, we can change the network structure. And so here in this example, if I swap these two nodes, then suddenly my estimate drops to 55%. Meaning that now we have a proof of concept that the structure of the social network can lead to this sort of systematic misperception. But of course, we want to not just look at toy examples, but also look at things systematically. And so what we want is to systematically simulate a social network where we have a majority-minority split, where we can prescribe how many supporters and opponents we have and see what structures can give us misperception. And so what we're doing is kind of iterating on the traditional way of looking at these. So there's a famous way of simulating random networks, the Barbasi-Albert random graph, which gives you a heavy-tailed degree distribution, which mimics some of the properties of real-world networks. And there is a 2018 change to this. So in this paper, what they did is they took the Barbasi-Albert structure and they added a way to simulate a majority-minority split in a way where you get to prescribe the majority and minority proportions, but also how willing people are to connect to those that agree or disagree with them. And so the kinds of networks that you get through this method look like this, where on the one end of the spectrum, you have this seeking out disagreement, where the agents in the network preferentially want to find those that they disagree with. Here, the size of the node is proportional to how many connections it has. So here, all the minority nodes here are really well connected. Compared to something like this, where we have complete echo chamber scenarios. So on the other side of the spectrum, we can prescribe complete homophily and say, only connect to those that you agree with completely. And so here we have two disconnected components in our network. And then finally, in the middle, we have this random graph, which is equivalent to taking a standard Barbasi-Albert random graph and just randomly distributing some opinions on it. Because in this network, the opinion of the agent doesn't actually matter. And so now we can generate the same kinds of histograms that we did for the survey, but now we can actually color them by opinion. And so what we have here is, for seeking out disagreement, we have all of the majority nodes convinced that they are in the minority. So all of the supporters of climate policy think that almost nobody supports climate policy. And we have also widespread misperception because the estimated mean is well below the actual mean. But the minority nodes, the opponents of climate policy, think that everybody supports climate policy. So we are not getting the kinds of misperception that we're seeing in the data. On the other hand, on this plot, we see the complete echo chamber scenario, where we have all of the minority nodes convinced that nobody supports climate policy, but the majority nodes think that everybody does. And on average, we don't even have misperception. So we're not capturing the thing that we want to see, even though this is maybe closer to how people might behave or how you might guess people behave. And here, randomly assigning opinions, we get no difference between minority and majority nodes. So we don't have misperception in either group, and we also have no difference between groups. And so this is the intuition for how we can see that homophily effects alone can give us either minority underestimating or majority underestimating, but not both. And I wanted to highlight a lot of other things, so I'm not going to spend too much time on this. But what we find is oversampling of minority opinion among best connected nodes can give us this sort of coexistence of minority underestimating and majority underestimating. And so from here, we might say, okay, we have a simple model that gave us a guess at a mechanism, but how do we actually assess whether or not this mechanism plays out in the real world? And so the rest of the talk is going to be about kind of separate attempts at answering this question. Do we live in a world where minority opinion is actually overrepresented among best connected nodes? And so the first way that we looked at this was news coverage. We looked at a corpus of over 2,000 TV news transcripts that mention climate change or global warming. And we selected the timeline that matches the survey timeline so that we could then couple the survey participant responses about their media diets to what we see in terms of policy coverage over here. And we looked at it in 3 ways. We annotated how the science of climate change was covered, how attitude toward climate concern was covered. For example, someone might say, oh yeah, climate change is real, but we shouldn't be too worried about it. That would be attitude toward climate concern, and attitude toward climate policy. And here we have all the yellow bars are kind of positive, so like acknowledges, concern, and support. All the blue ones are kind of negative, so we have denial, opposition, and we have neutral things and debate, and they're both in gray. And so what we see is that explicit denial of climate science is extremely rare, and this is consistent with what we find in recent literature. It used to be that you would have a lot more false balance, where every time you had a climate expert on the news, you might also get a climate skeptic, but this isn't really the case in our corpus. So you get a lot of acknowledgement of anthropogenic climate change. In terms of attitude toward climate concern, there is more opposition to climate concern than there is denial, but it's still extremely rare. But when we look at the attitude toward climate policy, we see that there is more opposition to climate policy than to climate concern, or than there is denial of climate change. And what we also see is that climate policy doesn't really get mentioned. So if you are looking at the y-axis here, you might already spot this, but I also put it over here. So the vast majority of transcripts do not mention policy solutions when they talk about climate. And so that might also kind of like shape the way that people think about it. But overall, this ratio of opposition to support tracks pretty closely with public opinion on policy, where we have about twice as much support as opposition. But of course, different media outlets, different climate policy coverage. So one of these things is not like the others. And Fox News really stands out, where when they talk about policy, they tend to speak in opposition to any climate policy at all. The other news outlets don't tend to have opposition to climate policy mentioned. And CNN talks about climate policy the most, but Fox News is a close second, which is surprising. I think going into this, I didn't necessarily expect that Fox News would talk about climate all of that much, but they really do. But you could look at this and say, okay, but you just counted how many times this was mentioned. Shouldn't you weigh it by views or ratings or something? And so what we did is we connected the survey data on media habits to news coverage of climate policy. And so we can look at it in aggregate. I had to group some news outlets together because of the way the survey questions were answered, but we can look at support, opposition, and no mention, and this is weighted by the estimates of how often people have tuned into these different outlets. And when we do this, we see that there is not really a significant divergence from like the public opinion. So again, there's about 3 times as much support as there is opposition. So we don't really have like an unrepresentative distribution between support and opposition that our model kind of hinted we might see. But we can also look at this individually. And so we can look at the support for climate policy in individuals' media diets. And this is a little bit tricky, but we estimated this in 2 ways. One is just compared to opposition. And if you just compare it to opposition, there is like a lot of support, and most people tend to have media diets that mostly speak in support of climate policy. But if you compare it to all coverage of climate policy, this average drops down. So it kind of depends on how you think about what it means to be exposed to coverage of support, so to supportive coverage of climate policy. If you think it's like, well, is it just for and against, then it's overwhelmingly supportive. But if you also count these neutral mentions as debate and debate as mentions, then less than half of coverage is actually supportive. And I think that this is just kind of a start of the conversation about how people might take this coverage and think about it. But I think that both of these ways are important to keep in mind, that there are many different ways to misrepresent something or for it to diverge from public opinion, and the story is more complicated than we might think. And then finally, we looked at the differences in how individual policies are covered. So policy is often mentioned in generality. I have some policy categories here. And the ones we came up with based on our first round of coding all of the different transcripts, you might notice are fairly general. So we have executive action, oil and gas industry. This means like oil and gas industry regulation. Paris Agreement, emission reduction, renewable energy. Green New Deal is perhaps the most specific one, but even the Green New Deal proposal was a bundle of multiple different policies. Then we have deregulation and laws, as well as regulation would fall here, and emergency declaration, which was referring to declaring climate an emergency at a very particular point in time. So you will notice that even the policies that get covered are typically not very particular policies or bills or proposals, but these were the categories that we thought suited the corpus the best. And so what we see here is that most policy is discussed in terms of executive action. So 75% of all transcripts that mention policy talked about it in terms of some executive branch action, either the president or other parts of the executive branch. And again, we can separate each bar here into support, neutral, debate, and opposes. And now we can look at differences between policy categories and how they're covered. So here we see that emission reduction is the least controversial. So it has more than half support. This is very similar to renewable energy. They also tend to get mentioned together a lot, but emission reduction is a little bit more frequent. And so it's overwhelmingly supportive, and there is very little opposition to it. Compared to something like the Green New Deal, where almost half of all its coverage is opposition to the Green New Deal. And it is the least supportively covered category in our corpus. The other surprising thing about the Green New Deal is that it wasn't covered all that much. So 20% of transcripts that talked about climate mentioned the Green New Deal. And sometimes it was even just as an example of like a catch-all for climate policy and what it could mean. So the Green New Deal was used as a stand-in for something else. And so even the most particular policy in this list of not very particular policies was actually discussed in a way that was still very general. And we can also look at which outlets cover different policies. So if we look at the Green New Deal, most of the coverage of the Green New Deal came from Fox News. So it isn't, so that partly explains why it was covered in such an oppositional way. But this was another surprising thing, which is Fox News latched on to the Green New Deal and other news outlets weren't really talking about it as much. And so although on average we don't see false balance, news about climate policy is not representative. So we don't really get something that neatly fits into our model narrative, but we're getting a part of the picture of that assessment of how unrepresentative is coverage. So most news segments about climate will omit policy altogether. And when they mention policy, it will often be polarized by media outlet and focused on executive action. So it won't necessarily be about the democratic mechanisms, but it will be about a particular person, like Trump pulling out of the Paris Climate Agreement and Biden rejoining. And executive action coverage is mostly, about political figures, and it's not necessarily going to tie that to the Paris Climate Accord or what it was or any of the details. So for now, I would love to shift gears a little bit and talk about a different way that shapes people's information environment. So we looked at news coverage, but now we're going to talk about social media. What we are working with here is a data set from Reddit. There are 5.1 billion comments and 10,000 communities collected over 14 years. Note that this data set is a little bit dated. Let's stick a pin in that. I will address this in a later slide. But in this paper, Waller and Anderson embedded all these data in a 150-dimensional space where each community, each subreddit, is one vector in this space. And if the two vectors are close by cosine similarity, for example, that means that they have a large overlap in user base. And so how can this help us examine the distribution of opinions about climate? The Waller and Anderson paper, I recommend checking it out, but it doesn't deal with climate specifically. So we want to borrow their technique of constructing social dimensions to address this. So we want to construct a social axis where we can place different communities along this axis. In order to do this, we're going to pick a starting pair, and the goal is to pick pairs that differ in the target dimension, but are similar in other respects. E.g., our Democrats and our conservative are both subreddits about partisanship and subreddits about politics, but they differ along this partisanship dimension. Because I'm in Colorado, I picked this example, but you can imagine our skiing and our snowboarding, where it's snow sports, it's very different, but there are two distinct communities, and they might have slightly different user bases. So that is really like your goal seed starter pair. And then you can augment this pair by looking at 10 most similar pairs of communities. And 10 is a little bit arbitrary, but it seems to work reasonably well. Where for our Democrats and our conservative, you might then look at Ask Trump supporters and Ask Hillary supporters. And if these vectors roughly point in the same direction, you can augment your initial starting point and construct this aggregate partisanship dimension. And then you can position other subreddits on this dimension. Because everything is a vector, you can just project it down. And so, for example, for the partisanship dimension, you get this lovely set of z-scores for every subreddit, and you have one pole, which is Democrat, and then here you have the Republican, and you can place every other subreddit here. This doesn't look super interesting at this point. It looks pretty Gaussian, very uneventful. But what we wanted to do is to look at how different dimensions interact. And so what we did is we went through 10,000 subreddits and their descriptions, and we annotated them to construct different dimensions that correspond to different climate topics. And so what we came up with are these 5 dimensions. So we have climate change, including things like science of climate change. We also have trust in science, energy, renewable energy versus fossil fuels. We have transportation. This is mostly in terms of public transit and private transit. And we have diet, which is vegetarian, vegan versus carnivore. And so now we can look at these still pretty Gaussian looking things, like this one, from climate advocacy to climate skepticism, and we can place the Democrat and conservative subreddits here. And so here we see, okay, they are positioned roughly symmetrically, with Democrats toward climate advocacy and conservative close toward climate skepticism. But here, if we look at diet, for example, what we see is that the z-scores overall are just much smaller, so we're closer to the middle here. So there's kind of less interaction with partisanship. So our Democrats is over here closer to plant-based, and our conservative is over here closer to carnivore, but it's not nearly as far out as the climate change axis. But this isn't a complete picture because I'm just looking at 2 partisan subreddits and I'm not really capturing a lot of the interaction. And so what we did is we binned the climate subreddits, and we gave each bin a partisanship score. And so here at 0, we have like averaging out or almost no partisanship. And then anything above 0 is leaning Republican, anything below 0 is leaning Democrat. And so what we see is for the climate dimension, we see almost like this straight line relationship where it seems very polarized, where climate skeptics tend to also lean toward Republicans and climate advocacy tends to lean toward Democrats. But this isn't the case for every dimension. So what we also see is that for the energy dimension, for example, we have a similar symmetrical polarization, but not as much. So here the polls were around 1 and -1, but here they're not reaching that far. So it's less partisan, even though it still has the same kind of polarized, symmetrically polarized trend. But the rest of them aren't polarized symmetrically. We have one poll leaning partisan and the other one not leaning partisan. So here we have the, for trust in science, trust side does not seem to be as polarized as the skepticism side. And overall, this doesn't seem to be very partisan. For transportation, we see that private transit doesn't really seem to be as partisan as public transit, which leans more toward the Democrat side of the partisanship axis. And then finally, for diet, what we see is something very similar to transportation, where the carnivore tends to lean a little bit Republican, but not nearly as much as the plant-based poll tends to lean Democrat. And so because this ends in 2018, something that we really want to do next is augment the data with the 2018 to 2025 Reddit dataset. Reddit has exploded in popularity since then, so we're dealing with a lot of kind of computational power issues because it really grew exponentially in those years. And so that's one of my summer projects is rerunning the embedding. And then we can quantify changes in climate dimensions. So for example, the carnivore diet has gone viral in recent years since 2018. And so what we expect to see is that the carnivore poll will tend more toward Republican now compared to this data set that ends in 2018. We also want to consider additional social dimensions like age and gender. This is a little bit difficult. Reddit tends to lean a little bit young, or like 18 to 34, and it tends to lean a little bit toward men. So there are some representations, but I think it still could be meaningful to look at these social dimensions, especially in relation to climate. And we've already started doing this. We want to compare this to polling data for these relevant issues, because for each of our specified dimensions, we can then compare Reddit to what we see in the polls and in the literature. And so it seems like I rushed through my talk today a little bit. I tend to do this sometimes, but getting toward the end, I just wanted to flag some future work, and some of it is maybe more along the lines of like dynamical systems that might be of interest to this audience. So one thing I wanted to flag is investigating self-silencing. This would be using opinion dynamics modeling, and again, comparing it to survey data to examine how self-silencing shapes public misperceptions. And so the proposed mechanism in the psychology literature behind self-silencing is that Republican supporters of climate policies might self-silence and not talk about those policies with their friends because their information environment has an unrepresentative share of climate policy opposition. So they might say, oh, they might disagree with me, so I'm just not going to talk about this thing to avoid conflict. But of course, the more you self-silence, the more you bias the information environment. So especially among young Republicans, there are a lot of supporters of climate policy, but there's evidence that they are not discussing it with each other. And so there are some fun mathematical questions in there in terms of like, how much self-silencing do you need to get how much misperception? That's something I'm interested in exploring. And then I want to further explore climate polarization on social media. Right now, we're looking at Reddit. There's also Blue Sky data. Blue Sky would be interesting to contrast because it tends very liberal overall, but there is also more climate-related discussion, so different nuances might emerge. And again, what we want to understand is which climate issues are most and least polarized, which correlate most and least with partisanship. And another natural direction would be to understand the coverage of climate policy over time. So now that we have a human annotated data set, maybe there are some machine learning and natural language processing tools that we can employ to automate it a little bit. We did experiment with AI tools at the beginning of this. I think that the way that these transcripts are structured, and because they are also transcripts of speech, the AI tool didn't do a very good job and would often get sidetracked, especially for things like analysis of attitude or picking up on sarcasm. But I think that with the human annotated data set to maybe like train it and augment it, we could maybe get somewhere with that, because overall 2000 transcripts was a lot for my team, but isn't a lot overall. So there's definitely like room to grow in there. And we want to track how climate policy narratives evolve over time. So even talking about it now, things like the Green New Deal or Paris Agreement are not the things that get covered now. So this is something that we would want to capture. So I'll finish on a few takeaways. Climate change is polarized, but echo chamber effects alone do not explain widespread misperception. Climate change is often misperceived, and unrepresentative information environment can help us explain this phenomenon. And climate change is not monolithic, but nuanced understanding of climate polarization can help us build coalitions. I am really grateful for all the collaborators. The names in gold are the collaborators on the misperception part. The gray names are collaborators on the Reddit part. And the blue names are my beautiful annotation team. I'm really grateful for such inquisitive undergrads, and I'm very happy that I got to work with them. And I will just end on this thing. I am currently running a survey trying to understand how funding access and funding eligibility affect the careers of current PhD students in mathematics and applied mathematics. So if you could forward it to your students, or if you're a student, if you could take it, I would really appreciate it. So yeah, thank you for bearing with me. And that's it.
Okay, let's thank the speaker for this wonderful talk. Thank you very much, Kath. Okay, at this time, are there any questions for Kath?
Yes, if I have a question, if I may. Thank you. Very interesting talk. I enjoyed it. This is not a topic that I'm working on, but certainly I'm interested in it. So I have one question. If you did the same kind of survey among, say, politicians, members of Congress and Senate, and the Senate. You can do that with using their websites. Would you find different answers or the same?
There is a wonderful paper. The name of the author escapes me right now, but what they did is they asked congressional staffers, so not quite politicians, but the people who worked for them and briefed them at the end of each day. And what they found is that there were relatively few differences between different groups of constituents, but the guesses were either 0 or 100. So the constituents were almost always very close to each other, within a few percentage points, and almost always in the middle. But the guesses were wildly different, like, oh, like all of my constituents support this, or none of them do. So I do think that there might be more polarization that you would see at that level as well, even though that study was about staffers.
Okay, thank you.
I have a question. So thanks, Kath. That was you've done a lot since I last talked to you. So, but anyway, I had a question about this the slide. I think it was about when you were talking about Reddit, but you had one called science where you didn't see much distinction between the two group. Yes, that's the one. So what's being asked there? You know, what does it? How much they understand about the science, or just whether they think scientists are biased, or what is the issue there?
Yeah. So the thing to keep in mind here is that the individual points are communities, so it's already very aggregated, and this is trust in science and skepticism. So it's not so much like, do they trust scientists, but do they, when they go on Reddit, do they engage in communities that are specifically oriented around things like celebrating science or conspiracy theories? And so there are a lot of kind of pop science subreddits that might share pop science stories, which is what a lot of the trust and science dimension subreddits ended up as. And the thing labeled skepticism here is a lot of conspiracy theory adjacent subreddits. So we don't have a perfect proxy, and trust in science was just kind of like the name we came up with, but it doesn't necessarily tell you that thing directly. It's more of an inference. Does that kind of help?
Yeah. So, I mean, do you think, I mean, I'm just looking to think, my general impression is that, at least among politicians, the Republicans at least say they don't believe in the science, and whereas the Democrats tend to. So basically, at least among people that work on Reddit, they don't. That doesn't follow. Is that correct interpretation of this?
I think that there is a nuance here, which is like, these are the communities that they seek out on Reddit. So it's very possible that they are not convinced that like anthropogenic climate change is real, but that isn't like a thing that they use Reddit for. So I think that is the missing piece from the interpretation. Where like some of the conspiracy subreddits are people doing this recreationally. They think it's really fun to ask questions, and it tends to be a community where there's a lot of reinforcement and groupthink and sort of yes and so those people would show up over here on this side. But the people who wouldn't show up are people who don't trust science, but when they go on Reddit, they just want to like read about their favorite TV show. They don't want to engage with the like anti-science communities. So I think that this is an important caveat for this pod. Yeah.
Okay. Thank you.
Great talk, Kath. Sorry. I don't have a well-formed question. I was sort of just struck in the beginning of your talk by the size of the neutral bars of some of those, especially given that I don't remember which ones it was specifically, but one of them, I think maybe it's like climate science or something, had a pretty big neutral bar. And as a scientist, I'm inclined to feel like a neutral. I don't know what neutral on science of climate change means here, right? It's not acknowledged as the science of climate change, and therefore, like, is it automatically not acknowledging, like denying it? I don't know. I'm just trying to sort of gauge that, and kind of my big takeaway from this was like, you know, it doesn't. like the science of climate change and towards climate concern aren't so polarized actually, unless you consider neutral as its own direction. And should we be thinking about neutral more? Does that make sense at all?
Yeah. And this is something that we struggled a lot in our rubric for the coding of the transcripts. And so maybe maybe it would help to, first thing I want to flag is neutral includes mentions in passing. So for example, a transcript might say Pope Francis talked about climate change. So that would count as a neutral mention, but I don't necessarily think that in that one sentence they should have said Pope Francis talked about climate change, which is definitely happening.
Right, yeah.
And so some of it is like confusing, but in the question of misperception, the way I think about it is that it might reinforce the status quo bias, but it doesn't necessarily like mean that we should make a normative statement that every single one of those neutral things should have been like in support. And so that kind of introduces this wrinkle, especially in individual media diets, where it's kind of hard to know how do you count neutral. And then some of the neutral are just kind of like, descriptions of what somebody else said, and sometimes it just says, well, this was the topic of discussion. So it is kind of difficult to disentangle. And a frustration that we had is that there are just so few kind of productive discussions of policy where climate is often already deprioritized, and then when you're looking at a transcript that mentions something, it's still mentioned at a pretty vague, general, high level. So only some of those neutral mentions are like intentionally trying to straddle the line and not go toward one or the other. But a lot of them are just kind of happen to be, well, it wouldn't necessarily tell you what the person reading this transcript like believes.
Cool. Thanks. Yeah, that helps.
Mm-hmm. Okay, may I ask a question? Okay, in your future work, we were talking about self-silencing. Could you go to that slide?
Mm-hmm. Yep, let me get there. Yeah.
Okay, all right. When you're going through your model, you're talking graphs, and you can represent attitudes with vectors. No, you said this is something you might want to address in the future, but how would self-silencing be represented or quantified in the model? Do you have that? At least do you have in mind how you go about that?
Yeah. This is something I've been really excited to do for a while, but unfortunately the reviewers have asked for a lot of edits on the data side. So for the last 6 months, I'm like, I'm a mathematician, I want to do math, but I've been doing a lot of transcript annotation and data cleaning. So So far, we have no opinion dynamics in the model. We just have distributions of opinions and how people connect to each other, but they're not changing their opinion. But there's a whole body of literature on opinion dynamics and how people might interact with one another and then change their opinion. And so the way to introduce self-silencing would be based on who's in my social circle and what I think their opinions are. I might choose to talk to them about something, which would change our opinion, or I might choose not to talk to them about something, which would kind of remove that interaction from the baseline opinion dynamics model that you would have. And so a lot of these opinion dynamics models simulate interactions that are pairwise, where there's a conversation and then either people change their opinions at the end of it or not. And so the self-silencing would be, this conversation didn't happen based on this agent's assessment of how the conversation would go, how stressful it would be, how much disagreement there would be. So it's all, I mean, like precluding this conversation.
So the model would show their hidden opinion that they do not show their peer, that they do not share with their peers.
Yeah, so you can think of it this way. There is you can think of it as like their expressed opinion, or you can think of it as like, we're only looking at the conversations that happen about climate change and we're ignoring all the other things that are shaping their social network. We're just looking at this like kind of this subset of their interactions. Yeah.
Oh, okay.
Okay. Are there any other questions for Kath? All right. Let's thank the speaker for this wonderful talk. Thank you again, Kath. Okay, we're scheduled to have another talk next week, and Christian will send the information. All right, guys. Thank you.
Thanks, everyone.